going to discuss about kinetic energy in pure rolling. Okay. So already we have discussed about kinetic energy in rotation. We all know that rolling means it is the combination of translational motion as well as rotational motion. When we call a rolling as pure rolling, it will consist of translational motion and rotational motion. So when we calculate the kinetic energy, it is also the combination of kinetic energy of translational motion and the kinetic energy of rotational motion. So kinetic energy of pure rolling is equal to kinetic energy of translational motion plus kinetic energy of rotational motion. Okay. So first we all know what is the kinetic energy of translational motion. Yes, in translational motion the kinetic energy is half mv square, right? So here v means what? Which is moving. Yes. Here that is the translational motion is in the center of mass. So VCM. Okay. So what is rotational motion? What is the rotational analog of this? Rotational motion like this rotational analog mass moment of inertia, velocity, angular velocity, right? So half into, instead of mass we have to write moment of inertia I, velocity we want to write omega. So this is the kinetic energy of pure rolling. Okay. Now we are going to find out the values which depends upon. So let us find out individually. Okay. So this is the kinetic energy of pure rolling. It is a combination of translational and rotational motion. This is the kinetic energy in translational motion and this is the kinetic energy in rotational motion. Now we are going to find out the kinetic energy with respect to two aspects. One is with respect to the moment, with respect to the center of mass and with respect to the point of contact. Okay. When it comes to moment, the center of mass, when we take the axis with respect to the center of mass, we can say, okay, the center of mass consider we can write, okay, when we consider here, okay, this is the center of mass, here there will be translational motion as well as, so when in the point it is moving with the velocity VCM, here there is translational motion as well as rotational motion. Okay, center of mass you consider the reference it will be having translational motion and rotational motion. Okay, so with the center of mass as a reference. Okay, when we take the center of mass as a reference, what happened to the kinetic energy? So the kinetic energy is here half m VCM square plus half, what is moment of inertia? In general we will write moment of inertia as mk square. Yeah, in the object moment of inertia general k square. So based on the shape of the object it will vary. Okay, so I have written this mk square. Okay, I am writing this mk square. Okay, into what is that? What is omega? We know that omega v is equal to what? R omega. Okay, so omega is equal to v by r. So instead of omega I can write VCM by r the whole square. Clear? So I have written this is translational. In case of rotation I have converted it into mass. So here moment of inertia mass I have converted it. Okay. Now we can take the common terms outside. Half is common, m is common, VCM square is common. Okay, the remaining term is here 1 plus here m is taken out. So k square is the VCM square by r square. Okay, so this is the kinetic energy of pure rolling when we consider the center of mass as reference. Okay, when we consider the center of mass as reference, this is your momentum, that is kinetic energy. This is your kinetic energy, because when we consider the center of mass as reference, there will be two types of motion. One is translational and the other one is rotational. Okay, so this is the kinetic energy for considering center of mass as reference. So now let us consider point of contact as reference. Okay, consider the point of contact as reference. So when we take the point of contact as reference, here there will rotate the there is no translational motion. Okay, so here what is happening? there is only rotational motion and there is no translational motion. Okay, no translational motion. Translation motion is not there, only rotational motion. When we consider the point of contact na நீங்க இத எடுத்துக்கும்போது இங்க வந்து என்ன ஆகும், இந்த இடத்துல வந்துட்டு இது ரொட்டேட் தான் ஆகும். There is no translation motion. So we can write the kinetic energy. Here there is no translation motion, so this becomes 0, half I omega square. Okay, since we are taking it as point of contact, I am taking it as I naught omega square. So now we can take the parallel axis here. Parallel axis na in the center of mass is parallel in the axis. So in the parallel axis theorem use panna. What is parallel axis theorem? That is I naught is equal to IC plus MR square, right? I naught is equal to IC plus MR square. In the axis parallel, அதாவது center of mass parallel இந்த axis இருக்கு இல்லையா, அதனால parallel axis theorem யூஸ் பண்றோம். IC plus MR square. Okay, so what is IC? Center of mass, moment of inertia of center of mass, that we can take it as mk square plus mr square. Okay, mk square plus mr square, and also we can write what is omega equal to dcm by r. Substitute these values, we will be getting, when you substitute it, kinetic energy equal to half I naught omega square. Okay, that is half, what is I naught? I naught is equal to mk square plus mr square into what is omega square? dcm square by r. Okay, so when you split it into two terms or take this is common. Okay, m is common, which is half m vcm square into k square plus r square by r cancel out, that is 1 by r square. So k square plus 1 plus, we take it outside. Okay, here when we take it outside, we can write it as 1 plus k square by r square. Okay, so this is what we are getting for the kinetic energy when we take the point of contact as reference. When we take the point of contact as reference, this is our kinetic energy. So when you see both the cases, okay, kinetic energy when you take the center of mass as contact, the same value you are getting. When you take the point of contact as reference, you are getting the same value. So in order to find out the kinetic energy, we can find out in two ways. Either we can consider the translational and rotational motion considering center of mass as reference. Center of mass reference எடுத்தீங்கன்னா translational வரும், rotational வரும். Okay, when you consider the point of contact as reference, there will be only rotation. So in two ways we can calculate the kinetic energy in pure rolling. Okay, hope you could understand how to calculate the kinetic energy in pure rolling, and thank you for watching.